This is Geometry, Chapter 2, Section 6, in which we will study the algebraic proof. Remember last time we talked about the beginnings of the idea of proving things, needing statements and reasons to support our statements, and trying to get from the given information to the final conclusion. Okay. We can do this not only in the paragraph form that we did last time, but we can also talk about it in an algebraic form. An algebraic proof is a special kind in which all we're using is algebra properties. So we're not going to have to worry with definitions of midpoint or any of that kind of stuff for these. Now there are a number of algebraic properties that we're interested in, and rather than tie up all your time having you read them off the screen while I read to you, I'm going to direct you to look on page 136. You'll find some of the properties, or a list of properties that we're interested in. Things like the addition property, the subtraction property, the transitive property. Okay, they're all found on 136. If I were in your shoes, on my note sheet, I would make sure to list those properties and what they mean so that you have them available to you on test day. So make sure you take some time and take notes off of that page of the different properties that we're interested in here. And we're going to use those properties to start developing our proof skills. Okay. So our job here is to prove the following statement. If negative 5 times x plus 4 is equal to 70, then x is equal to negative 18. Okay. One thing you may not do, and this is very important, I hope you're listening because someone will try to do this, and then they'll wonder why it got marked wrong. One thing you cannot do is just take negative 18 and substitute it in for x. What you would be proving is if x equals negative 18, then this stuff is true. You would be proving the converse of what you're trying to prove. You can only start from here, from your hypothesis, and try to get to the conclusion. You cannot start at the conclusion and then work backward. So make sure you're aware of where you're starting. You're starting at the if, the hypothesis, the given. So the first thing we're going to have in our proof is what we are in fact given. We have negative 5 times x plus 4 equals 70. That's our given information. Okay. You see, I've got my reason for how I know that's true. It was given to me. Now, when you see something like this, if this were algebra and not geometry, hopefully the first thing that crosses your mind is to distribute. So let's distribute. Distribute the negative 5, and you get negative 5x minus 20 equals 70. Okay. The next thing you would do in algebra would be to add the 20 to the other side. So we'll add the 20 over, and then you would divide by negative 5 to get to your answer, which is what you were hoping to get, x equals negative 18. You got there. The only difference between this and what you did in algebra before is having to tell me what step you did. Okay? You have to say what you did. You have to back up what you've done with the reason that that works. Okay? That's the big difference, is you have to justify it. You already knew how to do all these steps over on the left. You just have to tell me what you did. That's basically how an algebraic proof works. So I'm going to ask you to take a minute, pause your video, and try this one out, and then come back and we'll check and see how you did. So we're trying to prove if 5x plus 1 all divided by 2 minus 8 is equal to 0, then x is equal to 3. Well, we start from our given information from the hypothesis. Now, how would we work to get x alone? First, we would add the 8 to move it to the other side. Add 8, 0 plus 8 is 8. Then we would multiply by 2. Then we would subtract 1. And then we would divide. And notice every step that I said, I wrote to the side over here. I wrote that we added. I wrote that we multiplied times 2. Now, you don't have to put multiplication times 2. You just say multiplication, and that's good enough. And then subtraction, and then division. Okay. Now, we kind of hinted at this in the 2 that we've done here. We said last time you can do paragraph proofs. Another style is called the 2-column proof. And these resemble the ones we just did. Surprisingly, a 2-column proof has 2 columns. Amazing. In the left-hand column, you make your statements. And in the right-hand column, you supply your reasons. Okay, the only difference with what we just did in these is actually labeling it statements and reasons. So let's work through one that is in 2-column form so you can see what that's like. If 2x minus 13 is equal to negative 5, then x equals 4. Well, where do we start? The hypothesis. So 2x minus 13 is equal to negative 5, and that reason is given. Now you'll notice I have number 1 on those. When you write with 2 columns, you number your statements and you number your reasons to match, just in case your statement takes more space and then you have the reason for number 2 next to the statement for number 1 or something like that. You want to number them so that they can be followed. Well, how do we go from here? We'll add 13 to get 2x equals 8, and that was the addition property. And then what will we do? We will divide by 2, and that's the division property. Notice we got to the conclusion we wanted to reach. We wanted to say, in the end, x equals 4, and we got there. Now, suppose in the process of doing your algebra, you made a mistake here and you got 2x equals 6, so you ended up with x equals 3. That should be a giveaway there's something wrong, because your conclusion here needs to match this conclusion up here. So we've done a little bit more with proof. We've looked at algebraic properties and how to use those to kind of start getting you more used to the ideas of how to do a proof and having you justify your reasons, justify your statements with reasons. As always, if you had questions, I hope you jotted those down. Bring them in with you, and we will see you in class.